I'm on location outside San Antonio, Texas, where a construction crew is getting started unloading equipment to begin work on a new sewage lift station. This area may look rural now, but it's one of the fastest developing parts of Texas. New homes and new businesses require new utilities, including sewers, to keep up with demand. And in this particular location, those new sewers need a new pumping station to get the wastewater where it needs to go. Most people probably couldn't guess the path their dishwater or flushes take once they're down the drain, but I've teamed up with the San Antonio River Authority to give you an up-close view of one of the most important steps in the process. Come nerd out about construction with me and follow along the project from the very first scoop of dirt to starting up the pumps for the first time. I'm your host, Grady Hillhouse, and this is Practical Construction. The excavator's already breaking ground for the construction of this new lift station. Sewers normally work by gravity. They rely on sloped, underground pipes to carry wastewater away from homes and businesses toward the plants that clean it up. But wastewater treatment plants are major capital projects, and we don't build them everywhere, so there's not always a treatment plant located downhill from populated areas. In some places, it's necessary to pump sewage up to a higher elevation. That's the dirty but critical job of a wastewater lift station. This particular project is an expansion of an existing facility. When it's done, the new lift station will operate together with its neighbor here, increasing the capacity of the sewage system as the surrounding area grows. It will also create some redundancy by allowing either station to be temporarily shut down for maintenance during periods of low flow. Because sewers work by gravity, they're always sloping downward, so the end of a sewer pipe is usually deep underground. And that means this lift station starts with a hole. A big hole. The bottom of this facility will sit about 30 feet, or 9 meters below the ground, so this crew has a lot of work ahead of them. This soil is mostly clay, meaning it won't work well as backfill. Clay is difficult to compact. It shrinks and swells with changes in moisture content, and it tends to settle over time. So the engineers on this project specified a more suitable backfill material that will have to be brought in when the time comes. For now, the native soil from this excavation will have to be hauled away in trucks. These in-dump trailers can hold more than 20 tons of soil each, and it's going to take a lot of them to carry all this clay to dispose of off-site. One thing to notice about the hole, the sides aren't vertical. Safety regulations require that the sides of deep excavations be sloped to reduce the chance of a collapse while people are working inside. But that presents a problem, especially on a narrow construction site like this one. The deeper you dig, the less room you have to work at the bottom of the hole, since the slopes take up valuable space. On this site, there just wouldn't be enough area to get the vehicles and materials around the excavation if it were to go to full depth with sloped sides. So this hole has two parts. The first stage goes down 10 feet or 3 meters and uses sloped sides to avoid a collapse. The rest of the excavation will have to be supported using structural shoring. These blue parts being unloaded from trucks are part of a slide rail system that will hold the walls of the hole open as the crew continues excavating downward. The system includes steel plates called panels and vertical rails that make up the four corners of the box. The outer panels stay put, while the inner panels will eventually slide downward as the hole gets deeper and deeper. The first step of installing the shoring is to position the first outside panel. The location of this first panel is critical because the rest of the system will use it as a reference point. First, the crew puts a narrow bucket on the excavator and digs a trench for the blade to slide into. Then the first panel is carried into the excavation to be placed in the trench. It takes some trial and error to get the plate positioned in exactly the right spot. Once it's close, they use the excavator bucket to push the plate into the ground. And finally, the trench is backfilled to hold the panel in place with a few final adjustments from the excavator to get it plumb and true. The loader continues removing soil as needed, and the crew works to stage more pieces of the slide rail system. The next step is to install the first corner rail. Once secure, the second outer panel is next. These steel plates snap into the rail by starting at a 45-degree angle and rotating into place. That's easier than trying to lift each one all the way up and over the corner rails. In between installing each component of the system, the excavator and loader work together to remove more soil from the area. The crew hooks up the next corner rail to the excavator's arm and lifts it into place. Try to ignore your lazy host eating lunch in the background there. Once it drops in, the excavator again works to remove more soil from the hole. And now the third outer panel can be snapped into place. It's critical that this system be set up perfectly square, so the workers take the time to measure everything carefully. Then the third corner rail can go into place, quickly followed by the final outer panel, and the final corner rail. Now the system is locked together, but it's not ready for excavation just yet. Once all four rails and outer panels are in place, the sliding inner panels go in next. Where the outer panels will stay put to hold everything together, the inner panels will slide down the rails as the hole is excavated downward, providing support for the excavation and keeping it from collapsing. The crew has to work through a little rain to get these installed. It's a lot of work to install this shoring, especially when you consider how it's all going to be taken right back out. But when space is constrained like it is on this side, there just aren't many options to manage deep excavations, and there's no room for error when it comes to protecting workers in dangerous environments. Once the shoring system is in place, the crew can continue digging downward. The process is for the excavator to remove soil from inside the box, while the wheel loader carries the soil up and out of the way. As the bottom of the hole gets lower, the crew uses the excavator to push the panels and the corner rails of the shoring system downward to maintain support and keep the walls of the hole from collapsing. Sometimes all it takes is a little push. And sometimes, advancing the slide rails requires something a bit more percussive. As the hole gets deeper, the excavator operator can no longer see what they're doing, so another member of the crew uses hand signals to guide the operation. Every so often, the excavator hammers on the inner panels to slide them farther downward toward the final depth of the excavation. When the hole has reached its final depth, surveyors descend to the bottom to do one last check of the elevation. A mistake here would affect every part of the project, so the crew makes sure their measurements are correct. Once confirmed, it's time to compact the subgrade. To make sure the underlying soil will serve as a strong foundation for the lift station wet well, it needs to be compacted in place. There's not a lot of room for heavy equipment in this deep excavation, so the crew lowers a miniature roller compactor down using the excavator. This machine uses vibrating drums with pad feet to densify and compact the soil. It's also remote controlled, so the operator can stay out of the hole while it runs, keeping him free from diesel fumes that could build up in the small confined area. It's not the fastest machine, but it doesn't take long at all to compact the entire bottom of the hole. The next step in the project is to place a working slab at the bottom of the excavation. This slab doesn't need forms at its edges, but it does need to be set at the exact right elevation. So, the crew sets boards inside the excavation that will serve as a reference during placement of the concrete. They use a measurement rod to get the elevation exactly right. This concrete pump truck arrives first to get set up. It extends its outriggers for added stability, and then it extends the boom. Before long, the first concrete truck arrives at the site. But before the concrete goes into the hopper of the pump truck, the pump has to be primed. A lubricant is run through the pump truck to coat the inside of the pipes and hose. The prime is discharged into the bucket of the loader for disposal, and now they're ready to place concrete. Rather than trying to drop the concrete into place from above using a chute, this pump truck makes it easy to put the concrete exactly where it needs to go. The operator communicates with the finishing crew and controls the position of the boom. Each new truck unloads concrete into the pump's hopper where it's pushed through the boom and the hose. Also known as a mud slab, the purpose of this working slab is to protect the soil at the bottom of the excavation during construction. Without it, this clay would turn into a muddy mess in the rain, making it unsuitable for supporting the lift station before the excavation is backfilled. Since its only job is to serve as a working platform during construction, it doesn't need any steel reinforcement or a perfect surface finish. It just needs to have the minimum thickness as required in the plans, and most importantly, to have the correct elevation for what comes next. The three-person finishing crew works together until they can't fit into the corner. One worker leaves, then two, until the last one is left to finish the job. Once the working slab is cured, everything's ready for the next step of the project. And that next step is going to require a crane. A big crane. This 300-ton capacity behemoth just showed up on site. It's an all-terrain crane, barely small enough to travel on roads and highways. to reduce its traveling weight, the crane comes with an entourage of flatbed semi-trucks carrying outrigger pads and counterweights. Rather than sit on its squishy rubber tires during operation, this crane uses outriggers to create a stable base and keep it from tipping. These steel plates distribute the load from the outriggers so that the underlying concrete doesn't crack or break and the soil below doesn't compress too much. This crane also uses counterweights to balance the forces on the slewing ring. It lifts each plate and stacks them behind the cab. Once the pile of counterweights is complete, they're pulled into place using a hydraulic mechanism. Now, the crane is ready for action. The primary component of this lift station is called the wet well. It's essentially a large concrete cylinder. Rather than cast the wet well in place, this project calls for precast segments that can be stacked together like Lego. And the first one of those segments has just arrived at the site. In the next episode, the wet well segments will be swung into place by this huge crane, and lots more. That's next time on Practical Construction. If you're wondering what you just watched, I'll explain, but if you just want to watch the next episode, it's already live on Nebula at the link in the description. My favorite TV experiences when I was a kid were shows like How It's Made and Modern Marvels. I always thought it would be awesome to see a series about how big structures are built from start to finish. I kind of lost that hope when all the TV networks just started producing reality shows, so eventually I just decided to make it myself. Practical Construction is an experiment. It's not like anything else you've seen me do. We got really lucky to partner with the San Antonio River Authority and their general contractor who were willing to have our team on site, and we worked really hard to document all the fascinating details of this nearly year-long project. It's something we've never done before, and hopefully something you can't find anywhere else, and the best way to enjoy it is on Nebula. If you, like me, have given up on the TV networks but don't want to give up on high-quality educational content, Nebula's got you covered. And unlike TV, you'll never see an ad or interruption on Nebula. You've probably heard me talking about it before. It's a streaming platform built by and for independent creators. No high-powered industry executives deciding which projects get the green light, just people like me who are passionate about a topic they want to share with the world. Even if that topic, like a 5-part series about sewage infrastructure, may not be the best fit for the YouTube algorithm. And Nebula just keeps getting better and better. Totally ad-free videos from excellent educational channels, original series and specials that can't be found anywhere else, and even classes from your favorite creators like Sam from Windover Productions. I know there are a lot of streaming platforms out there right now, and no one wants another monthly cost to keep track of, but I also know if you're watching a show like this to the end, there's a ton of content on Nebula that's going to be right up your alley. So I've made it dead simple. Click the link below and you'll get 40% off an annual plan. That means you pay just one time, $30 for an entire year's access to Nebula. That's less than $3 a month. Help me show the world how cool construction can be and get the best viewing experience on the internet while you're at it by clicking that link in the description below. Thank you for watching, and let me know what you think.